Okay, are we good? Good. A drug product contains 0.5% weight in volume of an active ingredient. Sorry, the brain is firing. 0.5% weight in volume. 0.5% weight in volume of an active ingredient, that is API, in a 200 ml container. Calculates the content of the API in milligrams. Calculate the content of the API in milligrams. It's a very simple question.
Finish.
Yeah, what's the answer? What's the answer? Someone got 1 milligram. Okay. Adangwa, what's the answer? You are still on it? Okay. Yeah. Okay. $1,000 milligram. Any contradictory answer? 1,000 milligram. What's the answer? 1,000 milligram. Okay. Okay. Who else? Chomangwa, what's the answer? Abogojuganya, chai. Onyafa. Yi ngote. Nkina muka jena na start. 10,000 milligram. So that's alpha. 10,000 milligram. Okay. Onye partner. What did you get? 10,000. Hey, onye partner kanku. You are supporters kanku. James Joy Alpha.
1,000.
Oh, Pepe Rogan and that partner. Wow. This is LP. This is APC. Everything is correct. Is it LP APC? Okay. Alpha. Kevin or LP APC can party. Alpha. You can have. Okay. Deborah, sorry. Is Deborah she, not Deborah. What's the answer? Mama? Alpha. Okay, to save time, let's look at the question again. It says a drug product contains 0.5% weight in volume of an active ingredient. You remember our discussion when we started with dosage form, right? We said that the dosage form is another name for dosage form is what? Drug what? And another name for dosage form is what? Drug products or medicine. And they didn't specify the drug, the drug, they just used active ingredient. They didn't even tell you the type of course, you know that it should be a liquid what? Dosage form, right? Yeah, but we don't know the name of the product, right? Now we are told that the concentration there is 0.5% weight in volume. Remember the convention. Remember the convention that says that if you have the percentage as weight in volume, that 1% weight in volume actually means 1 gram in what? 100 ml. The weight must be in gram. The volume must be in ml. For that's what the convention said. If it's weight, but if it is volume in volume, it doesn't matter. The weight, the volume can be in any what unit. But the most important that the two of them must be in the same what unit. It can be in liter, but the two of them, before you do your calculation, the volume and the volume of the active ingredient must be in the same unit with the volume of the what of the entire drug product. That's, but if it is weight, the weight, it can be in kilogram, but most parents are, the two of them must be in the same weight, the same units. But if you have volume, weight in volume, because of that, this ratio, you know, it's not a proper ratio. You cannot cancel out. Hope you know. You can't cancel out. Gram, meal can never in this life cancel what? Gram. So it will subsist. So the best thing to do is that's why they came to that convention and agreed that, okay, if you have weight in volume, what it means is that the weight must be in gram and the volume must be in weight, a ml. And if you have 1% weight in volume, what it means is this: 1 gram in what? 100 ml. So if you have 1% weight in volume is equal to what? 1 gram in what? 100 ml. This implies that our 0.5% weight in volume is actually what? 0.5% weight in volume is what? 0.5 gram in what? 100 ml. Good. So there are 0.5. We have 0.5 gram of the API in 100 ml of the drug what product. If that is the case, you are asked something here. The container of that contains the drug product is what? 200 ml. So if there are 0.5 gram in 100 ml, how many gram will be in what? 200 what? Ml. Are we together? Good. So we find how many gram of the API that will be in the 200 ml container. So this should be what? Set up a proportion or simply cross multiply. You have what? 0.5 gram times what? 200 ml. So we have what? 0.5 gram times what? 200 ml. All over what? 100 what? Ml. So ml will cancel ml. We are left to what? Gram. 100 will divide 200. We have what? 2. So 0.5 gram times 2 is what? 1 gram. So we have 1 gram of the active ingredients in 200 ml what? Container. But we are asked to find it in what? Milligram. So we convert the what? The 1 gram to what? Milligram. And if you convert it, you have what? 1,000 gram. LP 71. LP 72. Alright, so the answer is what? 1,000 milligram. Okay. Any question? Any confusion? Let's trash it out. Huh? Who? Okay, you got it too. Good. Any is anybody missing out here? Let me explain. Is it clear? Is it clear? Good. So, okay, let's look at the second question I gave them to solve. I am not with the full question. No, I would okay, no problem. It's okay. The second question I gave them to solve it is to solve it. They just wrote the exam yesterday. Give me. No, I mean this thing. Get off here. Duster. Okay, let's look at this question. Okay, The question says, take thou. Take what? Thou. Ephedrine sulfate. 0.5 what? Gram. So can you see the board? Can you see the board?
Yes.
What are times 5? Okay, in that question we solved. Limit on the side question, sorry. You say what? No, 50. That's why we are here. 50. 5 gram. No, it's 0.5 gram we are talking about. I hope you know. Remember, it's 0.5%, not 5%. Have you seen the issue now? Is it clear now? The question of 0.5% up here?
Yes, 0.5%.
About 5%. Okay, okay, you see from 0.4. Okay, now so we.
Yes, she told us it's 5%.
5%. No, but actually she got it. But as per with the exam now is marking scheme they gave you that they will give to score. But you know the question. Have you seen that you can know something and still fail it? Yes, it happens. She developed her own marking scheme.
No, she put her own figure.
No, yes, now it's the marking scheme now, and she got it too. But for the exam, she failed it.
The procedure wasn't.
Life no balance. No, she knows it too.
Yes.
She used 5 gram. She 5%, and she got it, and she knows it.
Yes.
No. I'm about to say something here.
Yes.
What I'm saying, this is also, here now, it's not just about to. This is a revision. Calm down. Look at your question. Look at your question, critically. Look at the figure. Don't jump and start answering. Look at the figures again. Sometimes it happens to me sometimes. Am I not the one that called 0.5 here and started calling 0.7? The brain can misbehave sometimes. Calm down. Look at the question again. Look at the question before you start answering. Don't just start answering. Look at it. Calm down. 1 second, 2 seconds will not make you not to finish. Look at the question critically again. Look at the figures, Mama. What your eye is seeing, your eye is seeing, your brain is it interpreting it as what it should be. You may see 0. Your eye may be seeing 0.5, but your brain is interpreting what? 5.
Absolutely.
It happens. No. Sometimes it happens.
So that's what happened to me in the exam.
So be careful. I like what happened now, so that it's part of what I'm doing here. Calm down and check it again. Now, good. Now we have ephedrine sulfate, 0.5 gram. We have sodium chloride. Yeah, you can't record the words here. Success. Sodium chloride. But you can see this, right? Ephedrine sulfate, 0.5 gram. Sodium chloride. QS, sufficient what? Quantity. Then purified water. To 10 ml. Make isotonic salt. Yeah. Senior. Use as what? Directed. Now look at this question. The question now says, look at the formula on the board. The question now says, okay. Write down the formula first before I dictate the question. Take down ephedrine sulfate 0.5 gram, sodium chloride QS, purified water at 10 ml. Make isotone so saying use as what? Directed. Now let me call the question. The question says, are we good for the question? Good. How many milligrams of sodium chloride? How many milligrams of sodium chloride should be used in compounding the prescription above? How many milligrams of sodium chloride should be used in compounding the prescription above? How many milligrams of sodium chloride should be used in compounding the prescription above? Oh yeah, 2 minutes. Let's solve it. 2 minutes. 2 minutes. I'm all more LP win again for APC. Only with APC, confirm APC for you. Come on, more APC win for LP 77. We have 2 minutes. Let's make it happen. NPCE APC challenge. LP challenge. LP challenge. Woman leader LP. Woman leader APC. The what? Milligram. No, you know that 1 gram is what? 1 milligram now. 1 gram to mil. No, you have always known that you actually you can use the specific gravity of the formula for specific gravity. Formula for specific gravity. You know that specific gravity. So let's finish this solution first, okay? Before going into something else, we are in the spirit of isotonic solution. Let's tackle that isotonic before I miss something. Before I miss something. Okay, you want to because you are seeing gram. Oh yeah, APC Alpha.
Start giving my own party.
She want to form another party. She was saying, but I can't.
I can't think that
I'll give her. I'll give her chairperson. Women leader. It's joy for me. You know. Oh yeah. What's the answer? LP, what's the answer? Abga, what's the answer? APC, what's the answer? Abga, how far?
I got 90 milligrams.
Abga got 90 milligrams. APC Alpha, what do you get?
I got 0.09 grams.
APC got 0.09 gram. But say 0.09 gram, is it the same thing with 90 milligram?
No.
Are you sure?
Yes.
Oh, this is the same thing.
It's the same thing now.
Sir,
But the question say in what?
How many
The question say how many milligram? Okay, so Afghan and APC got the same answer. AP Alpha. Okay. This one is moving from one party to another party. This one is changing parties. This one has left ABC to Africa.
ABC, you're losing your.
Watch now. Watch now. She want to form a new party now. Watch now. She want to form a party. AP Alpha now. This morning. Give them a mercy. I don't want to go to court to tell me the answer now. I try to check court to tell me the answer now.
Yes, it's
90. Hey, what is going on? All the party got 90 milligram. Any different answer? Preach Alpha. So Alpha. What party belong to? No party. All right, now let's solve the question. Let's solve the question. Let's solve the question. Are we together? Good. Let's look at the question again. You know, this question has to do with what? Isotonic what? Solution. And you know that for a solution to be isotonic, at least there are different ways to determine that. You can go through the direction of what? Freezing point depression. You can take that route. You can also take the route of osmotic what? Pressure, right? Good. So this is the root of what? Osmotic what? Pressure. Am I communicating? Now, but you know, in this route now, you know, when you hear osmotic pressure, don't start looking at the pressure as in millimeter mercury. The pressure here now is that the solute, the concentration, you know, it depends on the concentration of the what? Solute in the solution. Now here this has to do with you using the concentration of the solute in the what? Solution. Applying sodium chloride, even though I didn't mention sodium chloride equivalent. Did I mention it in the question?
Yeah. No.
Did you use it?
Yes.
Did you use it? Okay, you know it, right? Anyway, it's a known thing altogether anyway, but no problem. So, what is the sodium chloride equivalent of ethylene sulfate? 0. what? So these. What is the sodium chloride equivalent of ethylene sulfate?
okay, ethylene sulfate.
Then how did this service?
So we use sodium chloride equivalent of sodium chloride.
Hey! No. See, let me solve it too. You never can tell. You know. Science is diverse.
2 point something or something.
No, it's not too much.
What did you use to get
Check our materials.
that?
Unajez here. How much? 0.2, right? It's 0.2. It's 0.2. Now, the sodium chloride equivalent of ethylene sulfate is what? 0.2. Now, to solve this question, look at it. APC is Kwanike. Now, first of all, this entire this thing, for it to be isotonic, it has to do what normal saline, right? 0.9% what? Weight in volume. Normal saline is what? Isotonic. Am I communicating? Now, for this thing to be isotonic, the entire system should also have this what? Are we together?
Yes.
Concentration. Am I communicating? Now, but if you use, because here now has to do with sodium chloride, this thing is for what? Sodium chloride. This 0.9% weight in volume strength of sodium chloride is what? Isotonic. That's why they gave you the sodium chloride equivalent of ephedrine sulfate. What it means is this: the sodium chloride equivalent of a substance is the amount of that substance that will give the equivalent, the exact osmotic, or they have the same tonicity with what? Sodium what? Chloride. Am I communicating now? Now see what I mean. See what I mean. Here now, 1 gram of this, we say that the sodium equivalent of this is what? 0.2. 0.2. Now, what this means is this: that 1 gram of sodium chloride we have the same tonicity with what? Of what? Ephedrine. Does it make sense?
Yes.
We have different solutions. This is solution A, solution B. Before they may have come as what? Solvent. Once you add solute inside it, normally the solvent is just there. There's no osmotic pressure. But once you add solute inside it, the solute will give you tonicity. Well, exact what? Osmotic pressure, and give you what you call what? Tonicity. And that tonicity may be equal to the tonicity of the cell, making it what? Isotonic. It may be more than that, making it what? Hypertonic. It may be lower than that, making it what? Hypotonic. Now, these two solutions now, for two of them, if this is sodium chloride, if you have 0.9 gram of sodium chloride in 100 ml solution, it's isotonic, because it has this equivalent tonicity with the what? Blood cell or body what? Fluid. Now, if you have another substance now, like ephedrine solution, placed by the side, ephedrine solution on its own will not have the same tonicity with what? Sodium chloride. You have to work on the ephedrine by adjusting the weight amount of ephedrine you are adding in the water for it to have the same tonicity with what? Sodium chloride. So you keep adjusting until you get to what? 0.2. Am I communicating? Am I communicating? Now, if that is the case, you now come and look at this thing now. What you can do here, ephedrine alone is not sodium chloride. You cannot use this to judge. You convert ephedrine to what? Sodium chloride by using its what? Equivalent. Does it make sense?
Yes.
By using its what? Equivalent. Now, if you multiply this by the 0.2, you get what sodium chloride this represents in this solution. So to know the sodium chloride this represents, multiply by each sodium chloride equivalent. If you multiply, you have what?
0.1.
0.5 gram times what? 0.1. But times what?
0.2.
0.2.
Equals to 0.1.
So 1 gram of sodium chloride, 0.2 gram of.
0.1.
I'm checking something. Be coming down. 0.2 gram of sodium chloride is 1 gram of ferrous sulfate. Then we have that S gram of sodium chloride is what? 0.5. Okay, there's something I checked. Please, I want to give you a standard definition. Please look at it. I just checked something now. 0.2 gram of sodium chloride is 0.2 gram of sodium chloride is equivalent to 1 gram of what? Ephedrine. Therefore, you are converting the ephedrine to what? Sodium chloride. Therefore, S gram of sodium chloride is 0.5. So X is this times this. So sodium chloride equivalent of ephedrine or any drug active ingredient is the amount. Sodium chloride equivalent of ephedrine is the amount of sodium chloride. Is the amount of. Please put this down, please. Put this down, please. I interchanged it. That's why I will go back. If you go back to the first definition I gave, I put this one here. So, but I confirmed something that I'm going back to the definition. Sodium chloride equivalent of an active ingredient, example ephedrine, is the amount of sodium chloride that exerts the same tonicity with one. Yes, that will exert the same tonicity with 1 gram of the what? Active what? Ingredient. Sodium chloride equivalent of an API, simple, is the amount of sodium chloride that will exert the same tonicity with 1 gram of the what? API. So if you are told that the sodium chloride equivalent of ephedrine sulfate is 0.2, what it means is that 0.2 gram of sodium chloride is exert the same tonicity with 1 gram of what? But I previously said that 1 gram of sodium chloride exert the same effect with 0.2 gram of what? Ephedrine, which is wrong. I just realized the mistake now. That's why I went back to the first principle to redefine it. Am I getting?
Yes, sir.
So you don't. Sometimes some things can be gotten from just by the lecture. You don't do cram it, because if you cram it, if you try to have it in your head, it may disappoint you one day. If you trace it from the first principle, it's clear that 0.2 gram of ephedrine of sodium chloride is equivalent. They have the same tonicity or simply equivalent, right? With 1 gram of what? Ephedrine what? Sulfate. Now, if that is the case, now convert ephedrine sulfate to what? Sodium chloride. What's the answer?
0.1.
So if you now develop a new formula like that now, if you develop the formula now, see what you have. See what you have. You now have that ephedrine. That this here is now what? Sodium what? True or false? 0. What? 1 gram, right? Here is this is still what? Sodium chloride. Is what? We don't know, right?
Yes.
Purify water to what? 10 ml. Now we want to check something. Shebi, we agreed that 0.9 gram, 0.9% weight in volume of sodium chloride is what? Isotonic. Yes. Now let's check that. That means 1 gram, 0.9 gram in what? 100 what? Ml, right? Now, but here we have 10 gram in what? 0.1 gram in what? 10 mil. So here now, the sodium chloride here is what? 0.1 gram in what? 10 mil. Now let's change this 10 mil to 100 mil. Let's find it in 100 mil. Let's know how many grams we can have here. How many will be in 100 mil? Huh? We are not solving question here. We are learning. Please don't make that mistake. We are not solving questions. If I am to solve it the way you are saying, you won't understand what I'm doing here. If I'm to solve it the way you're looking at it, then you won't understand this what I'm doing. So just follow the thing. If you understand it, you can sit down and cut it short on your own way. The best is to understand it and replicate it how you want it. Now, 0.1 gram in what? 10 mil, right? Now, how many will be in 100 mil?
1 gram.
Is it 1 gram?
Yes.
So 1 gram in 100 mil. 1 gram in what? 100 mil. And here is what?
0.9 gram. In QS now.
And here is what?
0.5.
This is 0.1 gram in what? In what?
Which one is it?
I'm coming, oh.
Okay.
I'm coming. Huh? Wait, 0.5 times 0.2 is what?
0.1.
Ah.
Yes.
Okay, so 0.5 times 2 is 1
No, it's
times
0.2.
0.2. I'm coming. 0.5 times 2 is 1.
Yes.
Okay, let's match it. Okay, 0.1. Because I'm sensing something here. That's what I'm asking. No, now, why tell me that it's 1 gram is 100 mil? It's wrong now. 0.1 gram in what? 10 mil. So how many will it be 1 gram?
Yes, 1 gram.
100 mil. Now here is 0.9 gram in what? 100 mil.
Yes.
Is this isotonic or hypertonic?
Is it 0.9? It's not my
Yeah.
Which one?
This one. Is it iso?
Okay, 0.1. No, we don't know how many. So one is it 1 gram in 100? Okay, no, it's hypertonic now.
It's hypertonic. That is 1% weight in volume. Excuse me. Okay, the next question I want us to answer is this. Is this solution the amount of ephedrine? We have determined that is what? A hypo. It can come in this form. The amount of ephedrine to be added to make it isotonic. What? 0. What? Perfect. We have brought everything to what? Sodium chloride. And this is what? High iso. This is hypo. What extra should be added here to make it iso? You must subtract. Everything is still in sodium chloride though. It's now 0.03 what? Gram in 100 mil. Now, put it back to what? Ephedrine sulfate. By doing what? Shoot it back to ephedrine sulfate. How will you do it? You will know that we have 0. We call Yeah, yes. Let's be our housekeeper. We have what? We only know that we have what? That 0.2 gram of sodium chloride is in 1 gram of what? Ephedrine solvent, right?
Yes.
Good. Now,
How many? No.
this is what? How many look at it here for? No, here is what? 0.03. Please, hello, please. Sorry, I'm not hurting, and I don't want to not hurting anybody. Please, in the class, what I don't like in the class is when everybody is not moving. I don't like it. When everybody is not moving, I hope everybody is moving. I hope everybody is with us. No, see what I'm saying. Hello. In class, we have different set of people. There are people before you even say A, they call BB for you. Such people them day. There are some people that are trying to find their feet. They also you can never deny it. So what I'm saying is this: please don't allow people that are saying if you take the answer to carry me away and you're not following me. Please, are you with me?
Yes, sir.
If you don't understand, ask me question. No, don't keep quiet and allow me to cap off fellow member. That is not teaching. That's why I like slowing down. That's why I break down to certain things. This step I'm doing, but I know why I'm going down to this lane. So if you are missing out, please, are you with us? It is sure. Are you with us? It is sure. Okay. Let's fly. Okay, not fly. All right. So now, having subtracted this, we move it to what? Ephedrine, right? So this is now what? X. What's the answer? 0. What? Good. 0.15 gram. So what you add here? Hello. What you add to this solution to make it? Hello. Now we got it to so what we add extra is what? 0.15 gram of what? Ephedrine. Add it to this. What's the answer? What do we get before? 0.4. Have you not seen it now? Yes. It's 0.45 gram that will be isotonic. So the one that we need to add extra is what? 0.15 gram. We have answered the second part of the question. The way this question can be twisted. Now, sometimes they may also ask you. What is the sitwell? Madam. Nanofuma. Anyabelo kerafia meet you my brother.
Yes.
Now let's continue. I want you to know my brother. Now let's go. Now let's continue. Now the next one, the amount of boric acid to be added, right? Now sometimes don't get confused when you see that question. In a formula, there's no boric acid there. Imagine what it concerns boric acid that this question. All is not so great that we know they use. How to do it is simple. It's simple. If you are asked, hello, are we together? Yeah. If you are asked the amount of boric acid to be added here to make it isotonic, first of all, calculate the amount of what? Sodium chloride to be added. Who? What is this? Speak. Have you collected your admission letter? Have you collected your admission letter from School of Pharmacy, not print out from your exam? Sorry, admission has closed. Come next year. Sorry, it's closed. Okay. You can see. Go to School of Health Information. I think they are still admitting. Now let's continue. Now, evidence survey is what? 0.3 gram. Remember, the question is this: boric acid to be added. It's simple. What you do is this. First of all, determine the sodium chloride to be added first. And we have done that here, right? What you do is what? Christiana, you must again, and you are here. Listen here. So, what do we determine? 0.06 gram, right? It's simple. Just convert it to what? Use sodium chloride equivalent of boric acid. Budget boric acid. Answer following. To be added is what? Subtract, right? You got what? 0.02, right? Gram. Okay, where?
They will give you the formula, but boric acid.
You may not see boric acid there. They may ask you, carry the amount of boric acid to be added in that formula to make it what? Isotonic. Everything still boils down to sodium chloride. You must use sodium chloride in a way. What you do is you first of all determine the amount of sodium chloride to be added, which we have done already. Good. We have done already here. We got that the amount of sodium chloride needed to added there to make it isotonic is what? 0.03 gram. Now we ayewalu sodium chloride equivalent of boric acid. We budget to what? Boric acid. That's the answer. Yes, it's also popular, but you should be given that. The sodium chloride equivalent of boric acid is 0.52. And you should be extremely careful. If you are not careful, the sodium equivalent of boric acid you may confuse it with what? Freezing point depression of sodium chloride, which is minus 0.5. To be careful. That one has no units. Okay? So sodium chloride equivalent of boric acid is 0.52, which means that 0.52 Chiamaka, I'm saying something, you are telling him. Listen carefully. And you are the one that ask question. I'm trying to explain. You are telling him, get your format. 0.52 boric acid means we have what? Means that 0.52 gram of sodium chloride has the same tonicity with what? 1 gram of what? Boric acid. So if you multiply this, is it multiplication or division? Check well. Check well. If you have if 0.52, I know why I'm saying this. There are some people, when we are moving you only do what? Multiply. Some people use only multiplication. You keep multiplying up and down, and you keep having issues up and down. Don't multiply. If you are confused, just break it down like this. You know what to do next. For boric acid now, 0.2552 gram of what? Sodium chloride is 1 gram of what? Boric acid, right? So we have what here? 0.03 gram of what? Sodium chloride should now be what? This times this divided by this. So you divide here, right? So 0.03 gram divided by 0.52. What's the answer? It should be 0. 5 what? 0.05. Leave it as 0.05 what? 8 or so. Now that is what? The amount of boric acid to be added to this to make it what? Isotonic. Be careful in the unit you are asked to find it. You may ask to find it in milligram. You move it to what? Milligram. And get so move 0.05 to 5 what? 8 gram to milligram. What's the answer? Just multiply by what? What's the answer? 58 milligram. So if you add 58 milligram of boric acid into this solution, it becomes what? So if they are preparing, see what they will now do. As they are preparing this solution now, they only need, having gotten this, they add boric acid, that's what? 0.58 milligram into this solution before final formulation to make it what? We call it tonicity adjuster or tonicity adjustments to make it suit to the tonicity of the what? Lacrima, blah blah blah. So it can do what? So it doesn't cause what? What can it cause if it's hypertonic or hypertonic? What? Good. Apart from that, just look at what happens. Look at what happens in some. Just study your cell and know what happens when a cell is placed in what? When a cell is just a cell. Hope you know. Is placed in hypertonic solution. What do happen to it? But you know that the eye is an organ. True of us. Good. You may not feel. Do you know why you will not feel it immediately? If you are using hypertonic one, the eye is an organ. Different cells will not die at the same time. But now, as you use it steady, use here. I get you now until go what? Blind. When almost something like amoeba, one cell, it will die immediately. But the eye has billions of millions of cells, right? So it will take some, maybe that's why that as using it steady a year, in after year, the thing, now to as they don't know what happened, they don't know what happened to the eyes. When it comes to expression, a lot of things are involved. I'm getting a lot of things are involved. It depends first of all the active ingredients. Depends on what it will degrade to form. It may degrade to form something that is poisonous. It will affect the person. Sometimes it may degrade to what is not even active and not to happen to the person. Are you aware? It's not all the expired drug that you take they will kill the person. It depends on what the active ingredients result after formed after degradation. If you form something that is not good to the system, that's where the problem comes. But the basic thing is that it will not be active. Am I communicating? That's the basic thing, because go from that compound or whatever to another thing. But if what it results into now is what will now determine whether the person will live or survive by way of harming the person. But if it's not active, if it is something that what the person is treating is something that can kill the person, that means the drug, we can now the drug in euphoria, not the diabetic. Sugar now right. So you won't know what's going on. Or the person will be taking chaff, and until the person will start having other diabetes complications. Maybe retinopathy. Name them. You've done the diabetes, right? What and what? Who never anti-diabetic? Neuropathy. Neuro. Okay, neuro, good. There are three. Neuro, cause. Another party. So this is what happened. I don't know if this is clear now. Yes. So this is isotonic solution with respect to what? Osmotic pressure and blah blah. We are also isotonicity with respect. What is the B value? What is B value? See. What is B value? What is B value of a? What was another name for nuclear equivalent? E value. Now, what is the B value of a substance? Okay, what is the B value of sodium chloride? Okay, it's okay. B value is the freezing point depression.
I was saying freezing point.
I'm going to put up here. I am going to complete it. I did what now? All right. B value is the freezing point depression caused by 1% weight in volume of a solution of a substance. So B value of a substance is a freezing point depression caused by 1% weight in volume solution of the what? Substance. So B value of sodium chloride is 0.576 degrees Celsius. 0.576 degrees Celsius. What it means is that you are ready now. Okay, let me. Okay.
So a B value is what?
I said that B value of a substance is a freezing point depression caused by 1% weight in volume solution of the what? Substance. And I give an example, sodium chloride. That B value of sodium chloride is 0.576 degrees Celsius. That means that 1% weight in volume sodium chloride causes freezing depression of 0.576 degrees Celsius. You can it's okay, but the rating is 0.576. Good. You can get that calculation. Try to, if 0.9% weight in volume of sodium chloride gives freezing depression of 0.52 degrees Celsius. Check here what 1% will give. It will give you 0.576. Thank you very much.
Thank you very much.
Are we which
I was thinking that we're going to
okay, are you okay?
how many
are they?
They are just 4.
All of them writing.
No, I think 2 is writing the person, then the 4
so that means 4 of them can write at the same time now.
Yes.
It's not an issue now. All right, thank you. See you next time. Chiamaka.